much difficult? I'm asking an opinion. This to be too much difficult, this question, this particular question. Yes, it is. It is a little bit difficult. Okay. So what? It is there. It was in the question paper which you are supposed to do. Because without doing this, you will not be able to master. So don't worry. There will be some, tough questions which we will be explaining. I will explain it n number of times. You can call me at any time. I'm okay with it. Okay. So there is no issue. Whether it is in the class, also n number of times I will explain it. I don't have an issue with that. So yeah, what it is, the dimension of this one is m L square t to the power minus 2 times at. This is, I'll tell you honestly, a to the power minus 1, t to the power minus 1. I'll honestly tell you one thing, why you people are feeling it to be difficult is due to another factor also. That is, since you haven't studied about the dimensions, some dimensions is to be studied or mugged up so that it will be very easy for you to understand. Okay, or it's easy to do accordingly. Yeah, what I'm just trying to say is that the dimension of v is what it is. Hello, am I audible in Google Meet? For a moment I was disconnected. I don't know about that. So it is ml square t to the power minus 3 a to the power minus 1, right? This will be the dimension of what? This will be the dimension of voltage. Okay, I just derived it here. This was present in the previous question paper also. No issues. So yeah, the dimension is ml square. Hello, just a minute. Okay, just a minute. I don't know what is with Google Meet. It is just again and again cutting one after another. Yeah, just give me a minute. Hello, hello. Am I audible in Google Meet? Yeah, just okay. Yeah. So the question is specifically to the students present in Google Meet. Did you heard how I derived the dimension of this one of voltage? Did you heard it completely? Hmm?
No, sir, at the end it was breaking.
Have you heard it up to here? Okay, I'll do it in a very quick manner. Just a minute. I think, yeah, I think now. So that is V is equal to W by Q. That it is m L square t to the power minus 2 is the dimension of work, and this is having a dimension of AT. Okay, so it is m L square t to the power minus 2 a to the power minus 1 t to the power minus 1 will be the dimension of potential or voltage. Okay, that's simple. Yeah, it is m L square t to the power minus 2 a to the power minus 1 t to the power minus 1. So it is asked that charge per unit volume is to be multiplied with this. Then what is that dimension? That is asked in the third option. So it is charge per unit volume means what? The dimension of charge is AT per unit volume means that it must be having a L to the power minus 3, right? So here A and T will be cancelling. Here also A and T will be cancelling. This L to the power minus 3 will be, if it is applied here, it will be M L to the power minus 1 T to the power minus 2. So it is also having the same dimension of the two quantities which we derived earlier, right? Hello. Okay. So the third option is angular momentum per unit mass. So now it is very clear that fourth option is the answer. Angular momentum L is equal to what? R cross P. So it is what L, or else there is another equation. L is equal to MVR. You study this one also. This we about this equations we will derive in the seventh chapter. So there is no big issue related to this. So it will be M L T to the power minus 1 times what? L. So it will be M L square T to the power minus 1. Now we already know that this is divided by capital M, or mass, angular momentum per unit mass. This never will be equal to M L to the power minus 1 T to the power minus 2, right? This never will be equal to that. Hence our answer is what? Hence our answer is fourth one, right? Angular momentum per unit mass. That is our answer. Or the odd one. Yeah. We will do the 10th one. Now we are at the 10th one, right? After that, we will stop. Okay. But there is one thing I want to say. Uh, as of now, I am receiving the answers of Madhumita, Shefali, Niranjana are only doing what? They are only doing the worksheet which I gave. So the rest of the students must complete it and they must give it. The last date is Wednesday. Okay. Because without practicing the problems, we will not be able to master this. If I guarantee you, if you done this particular book and if you done HC Verma, and then you are a master. You can answer any questions which comes. So yeah, the next question is the 10th one. The equation of stationary wave is given by y is equal to 2a sine of 2 pi ct divided by lambda times cos of 2 pi x divided by lambda. Okay. So simply I will tell you, if a wave is to be represented in the mathematical form, it can be represented as y is equal to a sine kx minus omega t. Here a will be the amplitude and y is the displacement. Here the x is the displacement, k is what? K is wave vector. Wave vector. The purpose of wave vector, this is the 15th chapter, but that we have to do it here since it is related to the dimensional analysis. The purpose of this wave vector is to find out the number of waves that will pass through a point in a unit time. Okay, the number of waves that will pass through a point in a unit time. So it is given by k is equal to 2 pi by lambda. It is given by the equation k is equal to 2 pi by lambda. Omega is the angular frequency, that is the number of cycles per second. It is 2 pi by 2 pi by t, or else it can be written as 2 pi nu, where nu is the frequency. Okay. So these equations can be also rewritten in another manner. So that is here it is written, if what I will say, what is the major, you know what is the major advantages of using the sine and cosine function to do a mathematical problem? Why do we need this cosine sine function? Hmm? Have you ever heard about something? I think the first chapter in maths is, just a minute. My card disconnected from the Zoom? No, no, I'm not. I think the number of participants is getting less, right? Okay. So, the major thing is that these are sinusoidal values, the values that are changing, which means it will be only having a maximum and a minimum value, maximum, minimum value, maximum, minimum value. There will be a maximum value and a minimum value, and these values will be alternatively repeating. Okay. I'll tell you what is the concept of sinusoidal, and for the day, we will call it a day now, because I think now your head will be having a lot of confusion. 0, 30, 45, 60, 90. I hope the you know already know the values of this from 10th class itself. Sine 0, who is the master in trigonometry? Tell me. Sine 0,
Two, sir.
cos 0, 1.
One,
Sine 30,
1/2, sir.
this one,
√3/2, sir.
45,
1 by
One
root
by root 2, sir.
1 by root 2, cos 60, sorry, sine 60, root 3 by 2.
root 3 by 2.
This one, 1, this one,
1.
0. Are you observing any patterns here?
Yes, sir.
What is that pattern?
The values are reversing, sir.
Yes.
Yeah, that is the pattern here. That is, alternatively, the values are getting repeated, right? For this is 1, this is 1 by 2, this is root 3 by 2. That is what, yes, that is in, when our teachers were teaching us, they used to teach us that cos is the bird that flies earlier than sine. Or in our words, in our regional language, മുന്നേ പറക്കുന്ന പക്ഷി കോസ് ആണ് സൈൻ പിന്നിലാണ് വരിക. So like that, whatever it is, what I want you to understand, the concept of sinusoidal means that it is alternatively changing one another. Okay, that is the concept of sinusoidal. So I think we will call it a day. Otherwise, you people will be having a number of doubts now. So is there any doubt up to this, what I have explained for the day? Is there any doubt up to this? We will solve all the problems. There is no issue regarding that. Hmm?
No, sir, no doubt.
Okay. Just a minute. After taking the attendance, you can go. Give me a minute. Give me a minute. Hmm. Today is 19th, right? You can expect these kind of questions, and I think we will be needing another day to dedicate for mathematics. Deepak was present, right? Dharun, Dharun Supreet is present, and Madhumit. No, Dharun Supreet was not present. Divakar is the one who was present. Madhumita present. Okay. Niranjana is present. Okay. The next person, Sharanya. Sharanya is not present. She was not present here. She's absent. Divyashree, Hira was present. Pravesh was there. Jiva Darshini, she was not present. Jiva Darshini. Jiva Darshini was absent. Bhuvaneshwari is present. Just a minute. I'll keep this call. This, this. Just a minute. Just a minute. Hmm. Yeah, I got it. Jiva Darshini is absent, and Gayatri is present, Divagar is present, Siddharth is present. The only person absent is Santosh, right? Hello? Yes, the only person absent is Santosh in J stream. Okay. So we will meet in the next class. Okay. Thank you.
Thank you.
Thank
Thank
you.
you, sir.